So we're going to see how to build a collaborative multi-agent system using electric agents progressively in steps, starting from just a vanilla Hono web app. Where we're going to get to is we're going to have a three-stage process where we have a manager agent, and then when asked to conduct a debate, so for example, it's the World Cup coming up, so debate Messi versus Ronaldo. What this is going to do is it's going to spawn a judge sub-agent. That judge itself is going to be given the topic of the debate, and it's going to start the debate by spawning two sub-agents. Those sub-agents themselves are going to be given a topic, so you should argue the Cristiano Ronaldo side of the debate, you should argue the Lionel Messi side of the debate. Then once they've made their arguments, they send them back to the judge, who then sends the argument to the other side of the debate to be able to critique, and then they send back their rebuttal, and then once the rebuttals are in, the judge summarizes the argument of the debate and decides on the winner, and sends that back to the manager agent, which then reports back the result. So this is just one example of a multi-agent spawning topology that you can build with electric agents. What I want to do in this run through is show you how you can build out towards that, starting with just a completely vanilla web application. So if we go from the top, what I'm going to do here is first of all just wipe my local setup, and then we're going to run the electric agent system just by using this npx electric ax agent start command. You can also use quick start instead of start, and then you get more kind of built-in agents. Just with this, the system starts off without any entities registered. So what we're going to see through this walkthrough is how we can define our own entities and then build up to be able to communicate with this sort of multi-agent spawning topologies. And so the way this works is that we're going to start with just a trivial Hono application. So this was just the simplest web application that I can think of. It uses Hono. You just have like a single root, and it runs as a local web server. So if we just run this here, then this is running on localhost 3000. If I go to say localhost 3000, we can see there's my application. Now, the first steps that we're going to do, because the way that electric agents work is you then define an agent inside your web application and register it with the electric agent's runtime. And so to do that, what we do is we first start off with these imports and configuration. So we're just going to import the kind of shim functions from the electric agent's runtime. We're just going to set up a bit of config so we know where things are running. And for this demo, I'm choosing to use Claude Sonnet 4.6, but you can kind of specify whichever LLM provider you'd like to use and model. And then what we do is we create an entity registry, and then we define our first entity. So I'm going to copy these over now. So that's the entity registry. Here we're just defining the simplest possible entity you could imagine. It's a general purpose AI assistant. The system prompt just says you are a helpful assistant, and we don't give it any tools at all. And then what we do is we create a runtime handler and pass the agent registry to that. And then we expose a new HTTP endpoint to receive webhook notifications to this runtime handler. And so that's basically all the shim that you need to wire electric agents into your web application. Except actually there's one last point, which is when the application starts up. Also, what we can do is register the entity types with the runtime server. You could also do this using some kind of migration tooling. So if I now save that, then what we will see in the electric agents interface here is that I now have an assistant entity type that I can create. What we're looking at here is just our standard kind of debug developer user interface. You can do all this stuff through the command line and the cloud as well. But if we just talk to this is like a kind of standard chat agent, and we can dig in under the hood, for example, where like it kind of shows all of the events that are happening on the thread and all of the kind of data that's accruing under the scenes. Okay, so far so good. Now let's do our first kind of sub-agent spawning. And so for that, what we're going to do is we're just going to extend our application a little bit. So first of all, I'm just going to copy over this helper function to generate sub-agent IDs. Then what we're going to do is just extend the system prompt of our assistant entity so that we can pass in any system prompt we want when we're creating assistants, because the assistants are just going to be our sort of general sub-agent entities. And then here we're going to define a new entity type, which is a manager agent. So if you think of something like OpenClaw, that kind of functions as a manager agent coordinating other sub-agents. And now, just to start with, just to show you how the system works and the kind of runtime APIs, we're going to spawn an agent just using imperative logic in the agent entity handler. So this is, as we'll see as we go forward, this isn't really the right way to do it, but this is like the simplest thing that you can do to just add sub-agent spawning as a first step to your application. And so the way that this works is that this function runs whenever there's a new user message or notification sent to a manager agent that you create. And then what we do is we just guard it to the inbox, because that's just user messages. And then we say every time you get a user message, spawn a sub-agent with the system prompt saying reverse the user message. And so you can see here we're using this context.spawn function, which just allows you to spawn sub-agents in the agent runtime. And if I now save that, this manager is just defined on the same entity registry, so there's no additional boilerplate or anything. And now we come back to our debug UI over here, and we see that we have a manager agent. And so if I send a message saying something like hello to the manager agent, then it spawns a sub-agent. And if we look at it, that sub-agent received the message hello, and it followed the system prompt by reversing it. Now, the manager agent then received a run completion wake notification from that child, like the child was completed, this was the response, but the manager agent here is confused by it because it doesn't understand that it spawned the sub-agent, because we spawned the sub-agent directly in imperative code instead of the LLM spawning the sub-agent using a tool call. So it's a bit weird, but I can ask it here saying something like, hey, did you spawn a sub-agent? And it says, no, it didn't. Like, it got a wake event, it saw that, but it just didn't sort of understand it. It seems that something is spawning sub-agents, so there's some intelligence going on there, but it doesn't understand it. So now let's just evolve to the next step, which is defining a tool for the manager agent to use itself to spawn sub-agents. And so for this, we're going to come in to this example. I'm just going to copy over, First of all, there's these imports for just defining schemas, which we'll just add to the top here. And then what I'm going to do is we're going to define a spawn assistant tool, and that's going to take these parameters where you basically pass in a task, which is a string. So this is for the manager to use. So we're going to drop that in there. And I'm going to grab this create spawn assistant tool. So as we can see, this is basically a tool called Spawn Assistant. It has a label and a description, which helps the LLM kind of know when to choose it. We pass in these parameters, which basically means it gets passed a task. And then it's within the tool call execution that we now do what we were doing before of calling context.spawn to spawn the sub-agent, and we pass in the task as the initial message. And then it returns a little bit of data to the parent agent spawning it, which kind of helps the parent agent understand what's going on. And then now if we look down at our manager agent, what we're going to do is we're just going to update the system prompt slightly. And then we're going to pass it the spawn assistant tool. So if I just grab these, let me just check that again, sorry. So, okay, I'm just going to grab this use agent definition and just, what we can do is we get rid of this imperative logic. So it's a much simpler definition now because we've moved the subagent spawning into the tool, and we give it a system prompt that says, when you're given a user message, just a single word, spawn an assistant to reverse the user message, or when you're asked direct questions, just answer them yourself. Okay, and so I can now save this. And now if we come and say, let's do a new session, and I take a manager agent, and we say goodbye. So it spawns an assistant to reverse the word goodbye, and it knows explicitly that it's doing it. It sees the assistant has completed the task, and it tells you what happened. And you can see under the hood here, we can see this was the assistant. It was given this as a prompt by the manager agent. It's kind of performed it. The manager agent gets the result, and it understands what's going on. If I say, did you spawn a subagent? The manager knows that it did. What's the subagent's URL? See, it knows the path to the subagent, which if we copy here is like the same path that we have here. So that's how to do essentially simple subagent spawning. But let's say we want to make a slightly more complex system. Let's say we want to make this multi-step subagent spawning where you have a primary manager agent. When you ask that manager agent to, say, debate a topic, it creates a judge subagent, which is then responsible for creating assistants to argue either side of the debate, as we saw up front when I showed you the end game we're working towards. Now, the first version of this that we're going to work towards is going to be a simple version using system prompt control flow. And as we'll see, like that isn't necessarily the end game of where we want to get to, but let's just kind of proceed in steps. So we already have this, the task parameters and the spawn assistant tool. That's here. What we're going to now create is an additional tool to spawn a judge. And when we spawn a judge, we're going to pass it a topic. This stuff is very, very similar to what we were doing before with the tool to spawn an assistant. So we're just going to drop it in. We basically have a schema here where you pass in a topic instead of a task, and it's metadata that explains like spawn a judge. And importantly, when we're doing the spawning here, we pass in this judge entity type to tell it to spawn a judge rather than an assistant. And then the next step is going to be we're going to define the judge entity itself. And as we'll see, a lot of the hard work here is being done in the system prompt. So in a sense, the control flow of the demo, this is like often where we kind of start with when we're building agentic systems, is trying to sort of pack it into the instructions that we're providing to the LLM, in this case in the system prompt or in the user prompt. Now here it says you are a fair, concise judge coordinating a debate. Goes through these steps, right? It's like, right, your job is to spawn exactly 2 assistant subagents. One to argue one side of the debate, one to argue the other side of the debate. It says, give them a clear brief with the topic and the side they've got to argue, get them to respond to you, end your turn, and then wait until you have both of the arguments come back, then summarize them, and then provide them back to your parent. Now, we try to do some of the usual stuff that you do with prompting here to get it to say, don't do the wrong thing, which is like, don't hallucinate the argument yourself. Wait for all of the assistants to return the full responses. And what actually happens as a result of this is actually quite variable, because sometimes the judge entity will follow these instructions and sometimes they won't. But so I'll say we have that judge, and then with the manager, what we can do is we're just going to slightly, I'm going to grab this use agent definition again, and we're just going to update it a tiny bit to give it the spawn judge tool and actually go, right, when you're asked to debate a topic, spawn a judge with the debate topic. When you're given a user message, do what you're doing before. When asked direct questions, answer them. So that's now the updated entity definitions with manager, judge, and assistant. And if I come to a new session, we see the judge has appeared. I can now come and create a manager, and we can say something like debate, say coffee versus tea. We can see that it's used the tool call to spawn a judge. Here's our judge entity. That's been given the debate topic again. That's used the tools to kind of spawn the assistants. The assistants are doing their thing where they're writing their argument and sending those back to the judge. You can see here then we got notified that one of the children was complete. This one was the tea side was complete, waited for the coffee side, so it followed the instructions. But it spawned randomly an additional assistant for some reason. I think it wants the coffee side to be generated again. Then it got notified by the coffee agent, synthesized the debate. It'll have passed that to the manager, but then it then got the notification from that extra third assistant that it generated. And it's kind of updated the argument. So this will come through here to the manager where, interestingly, the manager agent here spawned. It got one completed from the judge saying, I'll set up the debate. The manager agent then hallucinated the results to the debate, which is like, it was told not to do that, but it's like basically made it up before it got the result. So here it got the notification that the judge is processing the tea thing and kind of realized that it should wait. Then it got the next notification from the judge where it's given us the actual summary. And then it's like, oh, the judge has come back to me again. So it's kind of worked as a system, but as you can see, relying on the LLM to reliably follow the system prompts to implement the control flow of a multi-agent system is fundamentally unreliable. There's many situations where you just want kind of agents to be able to use their own intelligence, but sometimes you want to be able to constrain them to a more structured control flow. And that's what we're going to see in the next step, where we're going to move some of the control flow for this debate system into our imperative code using the durable state layer underpinning electric agents. So what I'll do is I'm just going to go through and basically talk through this code, and then I'm going to copy it over wholesale. You'll see that it's basically exactly the same code, just evolved a bit, but it'll just be faster that way. So we've got the same spawn assistant tool. We've got the same assistant entity definition here. Then we introduce a little bit more structured data. So we have a debate type. We have just a type for a finished child. And then we have a new tool called to start a debate. And so this is a tool call that's going to be given to the judge to start the debate, where the judge then provides the brief to both of the agents. And then inside the tool call, what we do is we spawn both assistants at the same time, but we also record the fact that we have started the debate. And we record some metadata about the entities and the status of the debate. Now, actually, with this example, what we're also going to do is make the control flow a little bit more complicated by not just waiting for the assistants to respond and summarizing it, but what we're going to do is we're going to ask the assistants to make their arguments. When they come back to the judge is then going to share the argument with the other side and give them an opportunity to make a rebuttal. And then it's only once they've got the rebuttals as well that the judge is going to make a summary and then report back to the manager agent. So that just sort of extends the control flow to make it a little bit more complex, which again is kind of one of the reasons why you might want to move it into this more imperative implementation. And so that's why when we insert this record here about the debate, we have a little map for recording the original arguments and then for recording the rebuttals. And then if we come down here to the judge, we have a little helper function for generating just prompt text. But then we have two different prompts that we provide to the same judge entity, one when it's starting a debate and then one when it's summarizing the debate at the end. And then the first prompt says, like, similar to kind of the previous prompt, but it doesn't need so much of the sort of rules to try and get it to get the control flow right. So what actually then happens is inside the handler logic of the judge entity, this is where we can just use imperative logic in the implementation of the agent entity to control the process. So the first thing that we do is we basically go, right, if we're receiving a user message, which is going to be from the manager agent, then we only want to do one debate at a time. And if there isn't a debate running, start a new debate. And so we're just like, okay, if there is a debate running, then ignore it, and otherwise create the debate. Then any other notifications that we're getting are going to be notifications back to the judge entity from the sub-agents that it's spawned. And so for these, the first thing that we do is we just ignore a bunch of states we're not interested in. If there's no debate or the debate is finished, ignore it. If it's not a notification of one of the children that we spawn through this, ignore it. And then also, just make sure it's a notification from a sub-agent, and then make sure that it's a notification from one of the sub-agents that we spawned. Then we get to the crux of the logic, which says, right, this debate has two stages, arguing and critiquing. Now, in the arguing stage, if we've received a notification, we basically want to just record that notification. So we record that notification in the state layer, and we go, right, this side of the argument, this is the response. Then we check the debate status and we go, right, have we got both of the arguments? If so, then what we do is we just imperatively send a message back to the assistants to say, hey, please rebut the argument from that your opposing side in the debate made. And then we update the state layer to say, right, this debate is now in the critiquing phase. And then we pause. And then if this guard here isn't true, then that means that we're now receiving a notification from when we are in the critiquing phase. And that means we go, okay, which side did we get the notification? Right, well, their rebuttal is done. We don't actually need to record the rebuttal in the state because the arguments and rebuttals will be contained in the context available to the LLM because they're part of the completion messages that comes back from the sub-agents. But in this case, we can go, okay, so have we got both of the rebuttals? Great. In that case, mark the debate as done. And then run the judge agent with the summarization prompt at the end. And so that's basically the definition of the judge entity. And then we have the same spawn judge tool as we had before. And then in the manager agent here, we just add a little bit of control flow to make sure that we're only responding to notifications from a judge entity if the debate is fully done. This allows us to still just monitor and communicate with the judge entity. And if there's some errors, state or failure conditions with the judge, we'll pick up on them because we're observing the sub-agents. But we basically say, right, if it's a kind of notification from a sub-agent, if it's a judge, then what we do is we use this here where a manager agent or any agent can observe the state of other agents in the system. So we basically get the URL to the judge entity, and here we observe its state. And that allows us here to check the status of the debate for that judge and say, right, if the debate isn't done, then just ignore the message. And that means that we avoid these steps where the manager started like hallucinating the steps of the debate, because it's only going to actually run the manager agent in response to a judge completion when the debate is actually full. And then it's basically the same system prompt and tools as before. And so if we just grab this and paste that over, and then we come back to our application again, I can now go here, we're going to create a manager, and we can say, let's debate, say good versus evil. And what we'll see is it spawns the judge entity. And then the judge itself here is going to start the debate. And as we can see, it's using the start debate tool now. So the LLM is still writing the actual brief for the sub-agents. And then the assistants are doing their thing where they got the topic and they've written this. That then responded to the judge. So the judge has had these two notifications, which were from the initial arguments from the sub-agents. It then sent the opponent's argument back to them, which got the rebuttal coming through. We've now had the rebuttals back because there's 4 wake notifications. That's when the judge can now summarize its verdict of the debate. And then when this finishes, it's going to report back to the manager agent, which, as we can see, hasn't responded to the intermediate wake event from the judge. But now that the debate is complete, it's going to present the results of the system back to you. And so what all this is showing is how you can evolve a standard web app from just a vanilla Hono app to integrate it into the Electric Agents runtime. You can define entities that run as agent logic within your web application or your serverless functions. And then you can evolve those out to use sub-agent spawning and complex topologies of multi-agent systems, where you can use a combination of the LLM intelligence with imperative control flow using the durable state layer to track the progress of the entity through defined workflows. And so this is how you can build expressive multi-agent systems with hybrid control flow using Electric Agents.